You must be familiar with this identity. It helps you calculate the cube of the sum of two numbers. Now what if you want to calculate the sum of cubes of two numbers? That is, what if you want to calculate a cube plus b cube? For doing that, we have an a cube plus b cube here. So we can write this as a plus b whole cube. We take 3ab into a plus b on the left hand side, and we can write it as minus 3ab into a plus b is equal to a cube plus b cube. This is what we have. Now observe that this is a plus b into a plus b whole square, and this is a plus b into 3ab. So a plus b is multiplied with a plus b whole square, and a plus b is multiplied with negative 3ab. So we can take a plus b common from the two terms and write it as a plus b whole square minus 3ab. This is equal to the right hand side, which is a cube plus b cube. You can expand it and check that we get the same thing. A plus b is multiplied with each of these. So this is what we have. Now we have learned this identity, a plus b whole square. So let us use this identity. It is a square plus 2ab plus b square, and then we have a minus 3ab. This is equal to the right hand side, which is a cube plus b cube. So this is what we have. Now here plus 2ab and minus 3ab are like terms, so we can combine these terms. So we get a plus b into a square plus 2ab minus 3ab gives us minus ab plus b square plus b square. This is equal to a cube plus b cube. So a cube plus b cube is a plus b into a square minus ab plus b square. Now this is a special identity, and we can memorize it and use it whenever we have to find the sum of the cubes of two numbers. So let us see how it can be used to calculate the cubes of these two numbers. We have a cube here, we have a cube here, we have a cube here and a cube here. So now we can compare 6 to a and 4 to b, and then we can use this identity a cube plus b cube. So 6 becomes our a and 4 becomes our b. So we can write it as a plus b, which is 6 plus 4 into a square. A square is 6 square minus ab, which is 6 into 4 plus b square, which is 4 square. So this is what we have. Now 6 plus 4 is 10. 6 square is 36. 6 into 4 is 24. And 4 square is 16. So this gives us 10 into 36 minus 24 is 12. 12 plus 16 is 28. So this is 28. So 10 into 28 is equal to 280. So 6 cube plus 4 cube is equal to 280. You can verify this answer by calculating the cube of 6, calculating the cube of 4 and then adding those. So we can use this identity whenever we have to calculate the sum of the cubes of two numbers. Now what if we have to find the difference of cubes of two numbers? How do we find it? Let us substitute negative b in place of b in this identity and see what we get. We have a cube plus negative b whole cube is equal to a plus negative b into a square minus a into negative b plus negative b whole square. So this is what we have. And now we can simplify it. So we get a cube. Negative b whole cube is minus b cube is equal to a minus b into a square minus a into minus b is plus ab. Negative b square is b square. So this is what we have. A cube minus b cube is a minus b into a square plus ab plus b square. We see it is similar to a cube plus b cube. The difference is with respect to the signs. The difference is just with respect to the plus and minus signs. Now let us verify this also. So we are familiar with this identity. For a minus b whole cube, we need to find a cube minus b cube. So let us take minus 3ab into a minus b on the left hand side. We get a minus b whole cube plus 3ab into a minus b is equal to a cube minus b cube. This is what we have. Now notice that a minus b whole cube is a minus b into a minus b whole square. This gives us a minus b whole cube. So a minus b is multiplied with this. Here a minus b is multiplied with 3ab. So we can take a minus b common from both the terms because it is multiplied with something in both the terms. So we have a minus b into a minus b whole square plus 3ab. This is equal to right hand side, which is a cube minus b cube. This is what we have. Now we know the formula for a minus b whole square. So let us use that formula here. A minus b into a square minus 2ab plus b square plus 3ab. This is equal to a cube minus b cube. This is what we have got after applying this identity. Now in this expression, minus 2ab and plus 3ab, these are like terms. So we can combine these terms. So we get a square minus 2ab plus 3ab gives us plus ab plus b square. And this is equal to a cube minus b cube. Again, this is a special identity because it helps us calculate the difference of the cubes of two numbers. This is a minus b into a square plus ab plus b square. And we need to remember this identity. So how do we remember the signs of these two identities? Here we have a cube plus b cube. So we place a plus sign here. A square is positive, so b square will also be positive because squares are positive. Now, if we have a plus sign here, we put a minus sign here. Similarly, For a cube minus b cube, since we have a negative sign here, we place a negative sign here. We put squares as positive, so a square is positive, b square is positive, and whatever we have here, we put the opposite sign, that is a plus sign here. So you can remember it as, if you have a cube plus b cube, you have a plus b and the reverse sign here, which is minus. If you have a cube minus b cube, you have a minus b and the reverse sign here, that is the plus sign. So we can remember these two identities and calculate the sum of the cubes of two numbers and the difference of the cubes of two numbers using these identities.